Hello everybody, back again with CP2b Newton's first law. Here we go. Let's start by stating what Newton's first law actually was. And it can be written as a moving object will remain will continue to move in the same speed and direction unless acted upon by an external force. And there's a second bit to this. A stationary object, so an object that's staying still. Stationary means still. Other words, static or stationary or still. Stationary object will remain stationary unless acted on by an external force. So not a force of its own. Alright. Now we've got definitions down, the not so entertaining bit, we can look more about what these actually mean. So, for example, if I draw here, this block here will stay there unless I poke it. So if this is my hand, this is a very, very bad hand, and I poke it, the block will move that way. Stationary object will remain stationary unless acted on by an external force, i.e. the stationary block will stay still unless it's acted on by my finger, which is the external force. Right there. I can underline it, that's cool. Right. Now we've got that out of the way, we can also do the same for a moving force. So imagine this is a frictionless plane, like we're talking very, very slippery. And I've got this block, this plank I suppose. If it's already moving this way, and there's no air resistance, there's no gravity, no friction, no anything, because those are all external forces. Gravity is an external force because it's pulling down, friction is an external force, and drag is an external force. If it's moving this way at 100 newtons, then it will continue to move this way at 100 newtons unless it's acted on by friction, gravity, drag, etc. So if that's moving that way, it will stay moving that way. Alright, that is going well so far. We can look at this also. An ice shot can go much faster than a sailing boat in the same wind conditions because ice has less friction than water does, and it can therefore go faster. What else can we look at? We can look over here. Circular motion is a bit pushy. Let's go with this exam style question. Let me have a proper read of this to make sure I don't make any mistakes. A man is pushing a baby along the pavement in a pushchair. Let's sketch this really quick. So we got the pushchair and the man. The man is pushing the pushchair along the pavement. Friction is acting on the pushchair. So friction is acting on the pushchair. The pushchair is slowing down. Compare the horizontal forces on the pushchair. Surely here, if we look for horizontal force, it will explain horizontal forces for us. Right, let's look here. Horizontal forces. We can probably guesswork this one anyway. Can't find horizontal force anyway here. Compare the horizontal forces on the pushchair. We can just say the man is pushing that way, and that's a horizontal force, and the friction on the wheels is pushing it that way. It is 2 marks, so I suppose we could get 1 mark for saying that he's pushing it that way and friction is pushing it that way. And we should probably get another one for saying that friction is making an opposite force. Nope, not for force. Friction's making an opposite force, so we can probably say push and friction. So that will probably get us our 2 marks. 1 mark for the diagram and 1 mark for saying that friction is making an opposite force. There is our 2 marks. Ta-da! Newton's first law. Undoubtedly, Newton's second law will be the next topic. So, I'll see you guys when we get to that, and I'll catch you in the next one. Bye!